that works.
This meeting is being recorded.
Okay, welcome everybody. This is the RDA P15 session, the joint session of the Repository Platforms for Research Data Interest Group and the Domain Repositories Interest Group. And I'm going to see if I can share my screen now. Oh, here we go. There. See if this works. Okay. Hopefully you can see my screen now.
Yes, sure.
Yeah. Good. Okay. Thank you. And so we're talking today about knowledge sharing to improve open data sharing across disciplines. And the presenters are myself, Bob Downs, Kirsten Leonard, Lily Zhang, and Devin Ray Donaldson. And let's see, yes. So as I said, this is a joint meeting of the RPRDIG and the Domain Repositories Interest Group. And the Repository for Platforms for Research Data Interest Group, the co-chairs are Lily Zhang, Devin Ray Donaldson, and myself. And you can see the list of previous co-chairs there. And then Kirsten Leonard is the chair of the Domain Repositories Interest Group. Peter Dorn was the previous chair. And our tab liaisons are Rosella Aversa for the RPRDIG and Gretchen Green for the Domain Repositories IG. So for those who aren't familiar with the Repository Platforms for Research Data Interest Group, what we're trying to do is improve the usability and technical capabilities of repository platforms. And they're doing this by collecting usage experiences, defining requirements, evaluating implementations, and identifying limitations of current solutions. And so we're offering recommendations, knowledge collections, and new working groups to investigate these issues. And the Domain Repository Interest Group is they're trying to have shared interests in data curation, dissemination, preservation, and institutional sustainability, and offering a forum for sharing practical experiences and developing joint projects. So today for our agenda, after this introduction, Kirsten Leonard and I will be talking about archiving Astro material samples data, the requirements for that. And then Lily Zhang is going to be talking about the SDG19 showcase, alignment of federated information infrastructures, research resources sharing. It's a mouthful. And then Devin Ray Donaldson is going to be talking about interdisciplinary scientific views on preferred repository features and have a discussion about the rubric for data repository appropriateness. And then we're going to follow that with our discussion on interdisciplinary knowledge sharing. So just consider a few questions here before we begin. For instance, how can we motivate data repositories to share knowledge with other repositories? What types of knowledge would be most valuable to share among repositories? And finally, how can sponsors help with this effort? And so I'm going to stop sharing now and hand it over to you, Kirsten.
Sure. Let me share. And is this okay, or should I go into presenter mode?
If you can go into presenter mode, it might be a little bigger.
Okay. I clicked on it, but it always takes a while.
Oh.
That's nevertheless.
Oh.
I mean, this is yeah. I'm
That's
excited.
good. Oh, there it is.
I don't see it yet on my screen.
Oh. Well,
So
I
now
see
finally, okay, we're all there. So I think this is already an example of what type of knowledge we can be sharing among repositories. What I want to present, or Bob and I want to present to you today about, is a study that we're currently conducting on identifying community requirements for a data archive that focuses on astromaterial samples data. Let me just give you some background on this. The reason why we're conducting this study is that there are currently NASA missions going on that return samples from space. Oops, some echo. Oh, it's gone. One of these missions is happening right now, and there are other missions planned. So NASA is concerned about setting up an archive that will facilitate the preservation, curation, and dissemination of data from these sample return missions, from the samples that are being studied when they come back to Earth. And NASA is currently very concerned about open science and open data. You may have heard about this initiative called Transform to Open Science, or TOPS, that has been initiated just a few months ago, I would say half year ago, maybe. The goal here really is to maximize the return on investment, and this investment is huge, as you can imagine, flying out to asteroids or flying back to the moon and picking up samples that get studied on Earth. So the driver really is to ensure that these data that are being generated on astromaterial samples can be used in the future and inform future science. All right. So the objectives of the study are to identify requirements for this astromaterials data archive. And there are basically two components to this study. One is to address the immediate needs of archiving sample analysis data from the OSIRIS-REx mission. This is a mission that's currently going on. This spacecraft had landed on the asteroid Bennu and has picked up samples, is on its way back to Earth, and will land next year in the desert of Utah to bring these samples back to Earth, and these samples will then be studied in labs all over the world. But there are, as I said, other sample return missions being planned, and so this archive also has a longer term scope and a bigger scope of potentially archiving all the astromaterial sample data collected by future sample return missions. So how are we conducting this study? It's we're gaining insights from the relevant literature. We're looking at NASA policies to ensure there's compliance with policies for open data sharing. We are addressing resource needs to meet standards and best practices for repositories, and specifically for sample-based data, capabilities to adopt applicable guidelines, and we need to understand the resource needs for the archival practices. We have two deliverables, and this kind of gives you a bit of context. On the one hand, we have a report that kind of describes the results of our landscape analysis, of interviews with users to understand requirements, the investigation of repository standards, and it will have recommendations to NASA. But a second phase of this is to create an implementation plan that outlines the resources needed and the costs associated with the development and operation of the astromaterials data archive, and an estimated timeline of implementation. So just to give you a bit of a feeling of what exists already as what we call the Astro materials data ecosystem. So one big player in this field is the Planetary Data System, which is a long-term archive of digital data products for NASA's planetary missions. And it stores all kinds of flight information, products, generated images, ground-based data, even from before missions, from after missions, where laboratory experiments have been conducted, and so on. It's a federation of 9 teams distributed across the US, and 6 of them are science discipline nodes. The others are more operational and administrative technical nodes that help with the implementation. So in this ecosystem of the planetary data system, there are some sample data that are curated at different nodes. So for example, spectral data at the geosciences node at the Washington University in St. Louis, or images of samples at the cartography node, but neither of them has a real focus on sample-based data, so it's fragmented across there. And any of the lab analytical data for astromaterials have actually never been archived because they were not considered to be part of a mission. They were post-mission data, so they didn't fall into the scope of the planetary data system. On the other hand, we have curation databases maintained at the Johnson Space Center that hold the sample catalogs. The Johnson Space Center is the facility that actually curates the physical objects, the physical samples in multiple collections, which you can see here on the slide: meteorite, stardust, the lunar samples, primarily the Apollo samples that were returned in the 70s. And these data systems hold sample information, descriptions, photos, the whole sampling history, which is actually not publicly accessible, how little subsamples of the specimens have been distributed to researchers worldwide. And then there are some compilations of data and descriptions in the so-called compendia. These are just PDF files ready for download. A newer player on the in this ecosystem is the Astromaterials data system. That's actually my own involvement as I'm leading this project. It's funded by the Johnson Space Center to finally make accessible and archive all the data that have over the last 50 years been measured and accumulated on these different astromaterials collections at the Johnson Space Center. The astromaterials data system provides a repository for users to submit and publish their data sets, but it also maintains data products for advanced data mining, and these are largely built by restoring legacy data from the scientific literature and from laboratories and so on into a big data synthesis, a relational database actually. And the astromaterials data system also focuses on creating community standards for lab analytical and sample-based data. Whoops, why did that jump back? And then as the newest player in the field, we have the sample analysis microinformation system, SAMIS, which is part of the overall data management system of the OSIRIS-REx sample analysis team. This is built to collect, store, process, and distribute the data that are being acquired on samples from asteroid Bennu, pertaining to the sample analysis phase that lasts from 2023 to 2025. And it will be, those data will be accessible only to the participants of the mission during that time frame. the SAMIS will deliver all data that they have to that astromaterials data archive that we are trying to define. And it will do so at the end of the mission in 2025. SAMIS is currently executing a special study that investigates data standards for all sample analysis products. And those are many. As you see here, so far, they have identified over 60 different data products. And the list on the right gives you an overview of what sort of the high-level categories for these data products are. A lot are images from either light microscopes, from electron microscopes, and so on, then spectrographic data, and lab measurements on the composition, be it the isotopic composition or the elemental composition of these samples. What they're defining in this special study are requirements for persistent identifiers, metadata, the data structures that serve as the bundles for archiving, and the workflows of review and approval. So all these different players came actually together in November last year in a workshop to think about astromaterials data management in the era of sample return missions. And this workshop has delivered high-level recommendations for the management of astromaterials. So this is these components that I mentioned here for the data ecosystem for astromaterials gives us input to our special study. So with this, I'm handing over to Bob to continue, as Bob has done most of the work so far on conducting this study. Bob, go ahead and let me know when I should switch slides.
Oh, great. Thank you very much, Kirsten. So yes, we're trying to elicit perspectives on the astromaterial samples data life cycle. And we're talking to people who are involved in all aspects of the life cycle. And so what we did is we composed lots and lots of questions. There were several categories of questions on different aspects of the data life cycle. And then we requested and received approval from the Columbia University Institutional Review Board to conduct a study, a human subjects study, and then we requested interviews from 32 community members, and 16 of them agreed to be interviewed by us, and they were interviewed anonymously. And so we conducted one of the interviewees, and we recorded the content in field notes. We're trying to keep it completely anonymous, and so the field notes are pretty generic as we're typing, as they're talking. And then we're conducting qualitative analysis of these field notes along with some relevant reports, which we'll talk about a little bit. When we're using deductive themed analysis to do that, we're basing a lot of our interpretation of the field notes on our own understanding, since Kirsten and I have both been working in the data management field for decades and doing research in this area as well. It's giving us a perspective that's allowing us to conduct this analysis by specifying themes that we would organize the different passages under. And we're doing this using the NVivo 12 qualitative data analysis software. Next slide, please, Kirsten. And so the interviewees, they're both from the US and from various other countries. And as you can see, most are from the US, but there are a lot from other countries as well. And they're seasoned researchers themselves. And so throughout their careers, many of them have served in multiple roles. For instance, we've got curators of the samples, curators of samples data, curators of other mission and planetary data, and then researchers who are either involved in sample collection, analyzing astromaterial samples, or using astromaterial samples data. Next slide, Kirsten. And the reports that we've been analyzing with the field notes are the NASA Science Mission Directorate Policy, known as SPD 41, the NASA Science Mission Directorate Strategy for Data Management and Computing for 2019 to 2024, the final report of the Planetary Data Ecosystem Independent Review Board, which just came out last year. And then the most recent report is from the National Science and Technology Council, and they just came up with these desirable characteristics of data repositories for federally funded research. And so with these and the field notes, we're getting a great perspective on the needs of the community. And we're also looking at a lot of other documents, and here are some selected ones, which some of you might recognize. For instance, the Open Archival Information System Reference Model and the Audit and Certification of Trustworthy Digital Requirements. Both of those are ISO standards that have been developed by the Consultative Committee for Space Data Systems. The Core Trust Seal Data Repositories requirements, the current ones, 20 to 22, and then the Global Earth Observations Data Management Principles and the Data Sharing Principles, and then the trust principles, of course, and we're also looking at the Holden memo from 2013 that's suggesting that we move towards open data. So that was it for that one, Karsten. Next, please. And were you going to talk about these at this point?
Yeah, I can. Do you want to go for the? Oh, you mean that I should talk about? No, go
Yeah.
ahead. Continue on.
So what we're doing is we're trying to identify the requirements from multiple perspectives, and in doing that, we're obviously trying to identify the user needs for all of the things that as repositories we usually do, discovery, all the way through publication and citation. But we're also looking at the data stewardship needs from selection, acquisition, accession, storage, all the way down through preservation and migration. And we're also looking at the resources, such as the different types of data and formats for them, as well as the requirements for metadata, software, documentation, services, tools, and support services that we would provide to the users of the repository. Next slide, please, Kirsten. And then here, giving you a little perspective on the data life cycle here from the Astro materials samples ecosystem. So, first we're looking at the return mission, pre-flight information, and then the mission flight information, and then acquiring the samples, and then archiving those samples, and then getting those into a sample database or repository. And then there's the sample analysis, which is the beginning of the data creation, moving on to data management, and then the use of the samples, which would include analysis. And from there, new data products can be developed and allow people to continue using those and comparing different analyses from different types of samples. And then I guess the next one is, yes, thanks, Kirsten. And so what we're doing is we're organizing the coding of the passages, the excerpts of content that we're gathering from the interviews into several categories along the data cycle. And we've chosen these very large categories in terms of looking at samples collection and data collection, then data acquisition into the repository, curation of the data by the repository, and publication. And then the last one is looking at ongoing management of the system. And I think that might be my last one, Kirsten.
Yeah, that's the last but one. The graph is the last one.
Oh, right. Yes. So yeah, if you could put up that one, we could just show the overview picture of how this is coming together. Okay, yes. And so if you look here on the left, you can see the data sources, the SAMUS project that Kirsten mentioned down in Arizona, and then the Johnson Space Center with their curation databases, and then researchers who are doing research on samples and producing data. And so those are the data sources, and those would go into the Astromet Active Archive, which would be preserving those and making redundant copies of them so that they're not lost. And then we would have a lot of linked resources for analyzing the data. And these include journal publications, the PDS nodes that Kirsten described, other sample databases, and other document databases. And these are all going to be available through the Astromet catalog, which will be distributed to the users. But they'll also go in, out to various indexes, data catalogs, and harvesters through metadata distribution. And so this is kind of a big picture view of how we envision the system going. But this is an evolution as we're learning more as we go along. We're about, I guess, halfway through the entire process, and it's very exciting to learn about all of these and all of the different types of data that are being produced. So this is a really great project, and we really appreciate Johnson Space Center for their support of this activity.
So I think
Kirsten?
yeah, I just wanted to end with saying, this is an example, I think, for, planning an archive, for evaluating needs. So we hope that the process we've taken and the methodology can actually be shared with other repositories that might come into a similar position where they need to provide requirements and implementation plans for specific archives. So with that, I think I can end the show, and then I will stop sharing. So that.
Well, thank you very much, Kirsten. And so our next speaker is Lily Zhang, and she's going to be talking about their system they're developing.
So,
Yeah, let's
okay, thank you. So good morning, good afternoon, and evening to all the friends. This is Li Zhang from CIC Chinese Academy of Sciences. And I would like to share you the talk about the alignment of federated infrastructures for research resources sharing. And the showcase we've chosen is about the SD13. And before getting started, I think that all of you can just propose a series of examples for the SD13 showcases and have a here just to show some of these examples. We could see that the UN SDG Help Desk, the World Bank Climate Change Knowledge Base, and a few others. And I just try to clarify them into three main categories. For this part, it might mainly focus on the knowledge and the information system. And for a larger scope, they provide the SDG 13 related data resources, download of different scale and services to support such online or offline data analysis, like very beautiful data interactive tools, data visualizations, and things like that. And for a few others, they may focus on some other things like best practices and worldwide case studies and things like that, even to support some decision making of regional or institution or different scale. So based on the current platforms for the SD13 use case, we could see there are still a few kind of challenges and probably also future opportunities. One is about insufficient policy and data supports. Probably we may request clear the policies and better collaboration models to facilitate the different levels of data sharing. And besides the sharing of the data entity itself, we also need some other things like the models to cure such data and the tools, algorithms to make the data analysis to different scenarios and for these different research objectives. And on the other hand, probably we already have a lot of open source of data online. However, when you want to collect them, like to support a real-time climate prediction, it may be still a little bit difficult. For example, there might be some data download limits, and it cannot support really the real-time data scenario. So we need to have a better design of such strategies to support the flow of data in a better situation. And the second thing is about the whole landscape for the story. We see that when we want to make SD13 platforms for services, probably we need to have federated resources of different kind. So maybe we need to redesign the whole story and try to get a more clear focus of what kind of resources we need and how to just merge them together. And another thing is the climate change is not things of local or in a small scope. It's always things that connect with each other. So we need better alignment and community outreach. So in this way, we need to answer the question about the reward system, how to attract the different participations of people, of institutions, and things like that. And on the other hand, maybe we need kind of like a small showcases and try to do something more. And based on this kind of analysis, this picture shows the general framework with the think about the resources federation. Probably for each of the SD13 platform, they will have their infrastructure layer computing and the data facilities to support the case. They will have different resources like the data itself and other information resources. And based on all this, they will provide the services based on particular algorithms and models. So if we have different showcases And one way is the federation could have like different computing and the data infrastructures connected together. And we can have like a distributed resources merged to the same objective, and maybe we can also have better collaboration between different models to support your research or objective. And for the SD13 showcases, I think the final objectives may fall into mainly three categories, like to support decision making and to enhance the capacity building of the local community, and also for the scientific research. So based on this idea, we see there are a lot of potential opportunities we can get together from different layers of research resources and services. And based on that, I would like to introduce something about the background of GEOS initiative. Actually, the idea was described very clearly in the UNESCO recommendation on open science for open science for open science infrastructure, that such things should be federated, accessible, internationally interconnected, and interoperable. And this way, the global open science cloud, the idea is to co-build and co-design and co-build a robust network of trusted research infrastructure. And based on such connection, we can have different research resources bridged. We can have different stakeholders connected based on the evolving research environment. And under the support of this initiative, the SD13 has been selected as one of the use cases. Within this use case, the concentrations may include research and studies based on the climate change and natural disasters, such as temporal spatial patterns of climate change, the collection and the open data for different topics, short-term and long-term predictions of different kind of climate issue, and monitoring assessment of the natural disasters and things like that. And based on our use case, expected deliverables may include, if we have different research resources and services between different collaborators, we can have different federations like the metadata and the data part. We can have the joint toolkit development to analyze the SD13 particular indicators, and we can explore the cloud federation techniques to support such SD13 analysis. And based on that, we also carry out the analysis within regional showcases, and this one mainly focus on like the Southeast Asia part. And between different potential collaborators, we found that they have already some resources or services on hand. Probably they have further demand analysis. For example, for different sites like this one, they already have some on-hand services about the climate forecasting part. However, there will be some more data space for storage needed and the computing facilities to support the better forecasting issue. And for another side, they have a demo platform focusing on different areas of the disaster mitigation part, but they have the similar things. And in from our side, as SD Cloud, we have the service provider team that could support to provide the kind of the computing facilities and space for a massive data storage. And there is also a sub-team for technical demo development. And besides, we also have some of these international partners to join. They have the platforms of their own, and we are trying to seek a better alignment between different research platforms and resources to see what kind of collaboration we can have to increase the social impact of everything under the umbrella of the SD13 topic. So based on that, the expected the deliverables within this showcases may include some of these functions enabled by the platform, like the climate prediction system for this area, the high resolution regional simulation system in this area, and another one for disaster. It's all just based on the current existing resources, but we'll have a redesign of the homework. But before getting started, let me still have a quick introduction to our technical, the cloud federation part. So when we want to have the federation between each, as I mentioned, from the infrastructure layer, we need the cloud federation to support like providing computing and storage facilities to support different kind of things. And the CST Cloud is trying to establish its own cloud federation that we can get interoperable solutions with different research environment and collect those computing facilities together and join them with other international partners. And currently we have a collaboration with EGI in Europe and try to establish the GEOS test bed based on which you can have your own virtual machines applied, and you can join as a whole group of members, and you can launch your instance based on tailored scenarios and things like that. And based on this, the resources may come from different size or different service providers, but we have a single sign-on platform that you can use to run your instance and have everything, the services under the unified monitor and matrix system. So so the whole SD story, the establishment of the demo shown here, you'll see supported by the GEOS technical platform. We are gathering data resources of different types. We will have the management tools of different kinds, and we will support the cloud services for different kind of things within SD13. Currently, the demo system is still in progress, and our plan is to have a first demo version this September and updated before end of this year for some tests, and there will be training on this. So based on this example, I would like to go back to think about the federation between different research resources. There are a few things we may have to do in the near future. One is the enhanced authentication and authorization infrastructure connection. The interoperability between different AI infrastructures will help to smooth the login from the user side. So different users from different organizations can get access to resources across domains more easily. A second thing is from the basic cloud environment, the federation should be more flexible to support a tailored scale of research. Like for the SD13, there will be large scale in-time, real-time data analysis. And for some of the others, they may be massive data, but for some of them may be high I/O, and for some of the others they may need long-term archives and things like that. Then it may vary in different situations. And the third ideas is that we need a better research resources sharing models. It's not only about the data itself, but also those affiliated things like the tools, the algorithms, and other things that could support the whole process of the research life cycle. And above all, no matter what kind of federation they do, it will always make the platform user-centric. And for the SD13 use case, the regional showcases, I think there are still a few things we would like to do in the following years. One is to redesign the use case for better alignment. The climate change is not a local story. We need more friends to, we need to listen to more voices. It may be users, maybe service providers, and it is only based on the collaboration of all can be better, have a higher impact of everything for everybody. And the second is, yes, it's similar to the previous one, to update resources federation model because it's more complex when we tend to different scenarios. When we have the software sharing, when we have the data sharing, when we have the infrastructure level, the computing facilities kind of federation is quite different. And probably we will carry on other regional showcases as one that is in schedule is about the collaborations with African partners to see if we can establish the African use case. And besides, we will have a few events, probably we will have a training workshop this end of this August and early September, and we will have the first ISOP, the International Symposium, probably next spring. Hopefully, it could be an on-site conference, and we will join a series of other talks following this year. And if you are interested in the geoscale or the SD13 case study, welcome to join this conversation. And many thanks to the global team for the use case and also for the regional showcases demonstration. And that's almost the whole thing. Thank you.
Great. Thank you very much, Lily. That was very interesting. We really appreciate hearing about those developments. And our next speaker and final speaker is Devin Ray Donaldson, and he's going to be talking to us about a study that he's been conducting. Devin, can you share your screen?
Yes, Irina.
Yes, I'm on hand. Just bear with me a moment, please.
Oh, great.
All right, so yes, that is the title and that's who I am and that's how to contact me. Next slide. So I'll talk a little bit about the background and motivation for my study and then a brief description, well, you know, the problem space, and then go into a brief description of the study and then talk about sort of the main output of the study, which was a data repository appropriateness rubric, and then hopefully have an opportunity for you to interact with the rubric and then conclude with questions. Next slide, please. So I know in many ways I'm preaching to the choir, but I know this also RDA and IDW also have people that are early career or doing things that are outside of the purview of what we have. So I'm kind of starting at a basic level and advancing. So it didn't used to be this way, but now there are so many choices for where one could put their data. Next slide. For example, according to re3data.org, there are nearly 3,000 repositories worldwide. Next slide. These repositories range from institutional data repositories like Duke University's Research Data Repository. Next slide, please. To domain repositories like Heap Data or I don't know if it's HEP or HEAP, I've not used it, but it's a repository for publication-related high-energy physics data. Next slide. To domain-agnostic repositories, such as the Dryad digital repository. Next slide, please. There are also commercial data repositories and services available, such as Figshare, Mendeley Data, and Open Data on Amazon Web Services. Although these repositories and services differ in the platforms they use, their business models, their functionality, and their capacity for data curation, scientists could conceivably use any of them to comply with requirements for making their data publicly available and long-term preservation with respect to their data management plans. Next slide. All of this got me thinking, what can I do to help scientists decide on what data repositories to use? Sometimes they don't have a choice, because if they want to publish in a particular place, they are very specific about you have to, deposit it in this repository and not elsewhere. But when there's more latitude, what repository should one use? How should one go about selecting it? Can I create a tool to help scientists settle on which data repositories to use? And if so, what would such a tool look like? And how can I make sure that the tool reflects the issues that scientists care about regarding where to put their research data? So I decided to get started with this. I mean, this is a big question and one I can work on for many years, but I decided to start with a study. Next slide, please. I conducted a focus group study with scientists from 5 disciplines: atmospheric and earth science, chemistry, computer science, ecology, and neuroscience. And we asked scientists from each of these fields questions about data management to lead into a discussion of what features they think are necessary to include in the data repository systems and services to help them implement the data sharing and preservation parts of their data management plans. Next slide. Participants discussed several issues and desired repository features, including metadata control, data traceability, security, stable infrastructure, and data use restrictions. There are more details about all of these topics in my paper, which I encourage you to read, but for now, I'll summarize what is meant by a few of these concepts. For example, regarding metadata control, my participants wanted repositories to harness metadata to support greater searchability and machine readability of data and entities within data sets. Regarding data traceability, my participants wanted repositories to provide information to them about how many researchers view, cite, and publish based on the data they deposit. And regarding security, my participants wanted their data to be secure. For example, they wanted to be sure that their data would not be publicly available before they had the chance to publish articles using their data if they were in an embargo situation. Next slide, please. I synthesized the findings from all of my focus groups. I did 5 focus groups, 1 per discipline, into a data repository appropriateness rubric. The rubric includes 26 questions organized into 5 categories: data deposit, access and ownership, metrics of use, metadata, and maintenance and security. For example, for data deposit, one question in the rubric is, do other researchers in my discipline put data in this repository? For some people, it's a non-starter if that's not true. And so that's why that is towards the beginning of the rubric, because if that's really important to you, then you're able to very quickly X that off your list if that's primary, in terms of importance to you. Regarding access and ownership, one question in the rubric is, does it cost money to access data? Or are there any data access fees? For some solutions are free or free in quotes, and others are not. And so if that's really important to you, then that's a really easy way to either check it on your list or X the possible repository off of your list. For metrics of use, one question in the rubric is, can I view reports about the amount of users interacting with my data? For example, how many access, cite, and publish using my data? Next slide, please. For metadata, one question in the rubric is metadata standardized with other data within the repository? For example, are user-generated metadata corrected for typos to enable discoverability in the data in search results? And for maintenance and security, one question in the rubric is, does the repository allow my data to be retracted or unpublished if necessary? Next slide, please. I know we're in a virtual session, but if you could pull your cell phone out and go to camera and use the QR code here or the bit.ly to actually look at it, because it's a bit abstract unless you're able to see it. And what I'm wondering is, and I know that the people that are here, you're in various institutions and liaise with scientists in various different ways. But maybe you could just take a look at it and consider if you think it could help guide a discussion about repository selection, either with your stakeholders or however directly or indirectly you interact with them. Because what I found was that the items in this rubric represent a consensus among scientists from these different disciplines about factors that are important to them when trying to select a repository. Now, is this a one-size-fits-all? No, because with focus groups, you get really detailed information from the participants, which may or may not generalize. But I do think that there is some overlap. And when we're talking about interdisciplinarity or things that could span across different disciplines, I do think that there are some considerations here that scientists across fields would be interested in. And I found that as a result of looking across the data. There's just some other things that came to my mind as I was doing this work. If you think that it could be useful to you and you'd be willing to try it at work, please let me know. I'd really like to hear about that and see if there's anything I can support you in doing such. And then I know that we're at International Data Week and it is in English, but there are so many countries represented and so many non-English speaking nations. And so it might be a worthwhile endeavor to try to translate the rubric in ways that would make sense in other countries, so that it will, I think the scope of the instrument will not be bound by English or those that can read it. And so, yeah. Next slide. So the data repository appropriateness rubric represents a consensus from researchers across 5 different disciplines on what they want from repositories. Like I said, it's not a one-size-fits-all, but it definitely is a start. And I'm hoping that anyone who uses the rubric can decide. When you use it, you can take a look at each item and see whether it matters to you. You can skip those items that are irrelevant. And then you can also provide comments for each item if there are nuances for you as a scientist in the issues that are raised by any particular item. I think that the rubric can be used to get researchers to think about what they want and what they don't want from repositories. And my hope is that my rubric will help people consider the relative merits of multiple repositories, because we're in a space and a time where there are increasing options about where one could put one data. And so hopefully something like this can get you to think about which one to settle on. And in particular, when you're not sure which one to use, and there's a lot of different options that are out there. Next slide, please. So this project is based on work supported by the Institute of Museum and Library Services. Thank you for your time and attention, and please let me know if you have any questions.
Oh, great. Thank you very much, Devin. That was really interesting.
Thank you.
And I was wondering if I could ask a question about your study right away, but it's kind of different than your rubric, which I'd looked at before. But what I'm wondering is, when you're speaking to the researchers, are you getting a sense about how researchers who are working, say, within a particular domain might be interested in just depositing their data in a repository that represents that domain for which their work is focused?
Yeah, there are, I did have some participants that wanted to put their data in a domain repository. And so that's definitely what I was getting at with one of the questions in data deposit that says, do other researchers in my field, put data in this repository? That's one way of saying, in a way, like, I want a domain repository. For the ones that say yes, and that's important to you, that's probably why. And some fields are a lot better than others in having domain repositories, and some have multiple domain repositories. So there's a lot to choose from within their fields, or some, it's just, we know it's that main one if it's our field, or there's two. So yeah, there were definitely some participants that were very interested in utilizing domain repositories.
Just to follow up on that, sorry, but were any of the participants indicating that, I know you mentioned there's lots and lots of domain repositories, there were lots and lots of repositories, over 3,000, but in terms of domain representation, did any of the researchers seem to indicate that there weren't enough for their particular domain, or that they felt that maybe their domain wasn't represented effectively for providing data?
I think there was a lack of awareness. That was one thing that came up. They were like, we should have more people like you come and talk to us about what repositories are and help us identify what ones would be available to us in our fields. So I think what I encountered with my participants was just, wow, there might be other repositories out here, and they could be in my field that I'm not aware of. So it'd be nice to just kind of have a session on repositories, or that's kind of the sense that I got more than anything. I mean, there's some people that were like, this is the one that we go to, and it was pretty clear to them. But there was a lot of people that said, I hadn't really thought about this. I keep things more on my servers, but if there was an opportunity to use one in my domain, I should. So I still think there's a need for more awareness raising about repositories and which ones are appropriate given what field you're in.
Oh, great. Well, thanks. And I see another question in the chat, and that's from Bob Chen. Bob, did you want to ask that of Devin, to give Devin a little more context on that, or alternatively, we could read it.
Yeah, I mean, it's sort of a follow-on to what you were asking about, people wanting to put their data with similar data in a domain, not just a discipline, but also just obviously we know people get hung up on journal impact factors and that sort of stuff. So I was, interested that your rubric didn't contain sort of that, what you might call reputational factors that much. And I don't know if that was a conscious decision or just something that didn't come up in the discussion, but it just seems like something that, especially with data impact factors, you could start measuring the median impact factors or something of data in a repository and start comparing those, or people could just say, I'd rather have my data in the one where all the science articles put their data and that sort of thing.
Yeah, it didn't really come up, some of these metrics or the selectivity and stuff. It was more so, if I want to publish in this journal and they say I need to put it there, then that's where I'm going to put it. Or, are other people in my field putting it there? Which I think some of these, as a byproduct of doing that, if you're putting it in the preeminent repository for your field, there probably are some of these other things at play. But they didn't say, I am actively seeking the repository that, has highly cited data. But maybe that's why it's important to do these studies over and over again, because maybe in a couple of years, or maybe 5 years, 10 years, 15 years, maybe that will be more salient in people's minds. But I think there is, even though there's so many people that have done so much work on this for so many years, there is still a need for more awareness raising about repositories that people can harness and leverage in their particular fields, and also everything they can offer, and the variety of services that one can enjoy when utilizing a repository. Anyone else? Oh, Bob, you're talking, but we can't hear you. Bob Downs, that is.
Yeah, I muted myself. Sorry about that. Yeah. Seeing that there are no other questions in the chat, I guess, first of all, I'd like to encourage others to ask questions as well, or raise their hand if they want. But in the meantime, in terms of sharing, the focus of this session is on sharing knowledge. And I'm wondering about the attitudes of those who you've interviewed or had participated in your focus groups regarding the sharing of their data. Did everybody, well, I guess one question would be whether the selection criteria for getting in a focus group meant that they had to be positive about sharing data. But if it was more open, I'm wondering about the attitudes, the differences in the attitudes in terms of sharing.
Yeah, so I think that all of my participants, well, in the paper, Arena, maybe you can put up the slide that has a QR code to the actual paper. For those, I tried to put those in there so that you could, access these things. There's definitely more details there, but I went to the websites of the major conferences in these fields, and I generated a convenient sample from those that presented within them, and got them to participate in the focus groups. And I guess my criteria was that they were, had advanced degrees, either had them or were in the process of seeking them in those fields, and such that they would be presenting at these conferences as well. And I found that my participants were very positive towards the idea of sharing data, even if they themselves don't actually do it, or don't do it as much as, even if their action doesn't match their enthusiasm for it. And I mean, we've seen that in the literature as well. People say, oh yeah, it's a good idea to do it, but then I don't do it as much. But there were some people that were practicing what they preached as well with respect to sharing data. Does that answer?
So the study probably wasn't looking at individual characteristics so much because it was focus groups, but did you get a sense that there were differences in perspectives, either based on the disciplines or data sharing perspectives, that is, based on either the disciplines or some other characteristics? Perhaps in the disciplines, when you have different or individual disciplines represented in each focus group, that might be more obvious that way, but there might have been some other differences that were kind of more subtle.
So, and hopefully this answers the question. So like for the computer sciences, they, compared to other disciplines, they didn't feel like they needed this. Like they're very technical. They feel like I can do whatever I can do it. I don't really need a repository. I can do whatever I need to do because I'm very technically oriented. So if there, and I kind of picked them by choice because I thought that would be what I'd encounter. So if I could plot them in terms of like disposition towards data sharing, I would say that the atmospheric and earth sciences discipline was the most disposed and amenable to data sharing and the use of digital repositories in service to that. And on the opposite end of the spectrum, the computer scientists, because they just feel like they can build their own and do their own thing, and then they don't realize that a repository isn't a database; it's services. It's a myriad of services that cascade on top of it, and it's not just purely technical.
I see.
Mhm.
That's interesting. I think there's some, and it may be subtle for some, but when you're sharing through a repository, that opens up the capabilities for users to do a lot, and maybe for even a lot more users to find out about the data. And we could go on and on and on about the benefits of that, since we're repository groups here. But if you look at somebody just putting their data on their own server and saying anybody can use it, I think that's a little different in terms of what we think about as sharing.
Yes.
It's like if you stand in front of your house and say I'm sharing lemonade, only
Yeah.
the people who drive by will stop for your lemonade. Where if you have a big billboard on the highway, it's going to be a little bit different, and a way of serving the lemonade quickly, etc. But I won't dominate the discussion. I see another question from Bob Chen for Lily, and I'm wondering, Bob, did you want to ask that of Lily?
Well, I don't know. It's self-explanatory. I'm just curious about how she thinks, the focus on SDG 13 relates to the other SDGs, data efforts in those areas.
Yeah, so Lily, did you hear that? Can you see it?
Yes, I think the question is quite clear. And as I mentioned about the federation of different levels of research resources, I think that is a very good question. Only for the SD13 itself is not a, a single kind of thing. You need to connect with different communities, different users, and different service providers to get it merged. And between different indicators, I think there is kind of interconnections also. And the collaboration may, include different parts like the users. From the user side, they just may want to know better about the whole SDG thing, not only a single indicator, a single goal. So for any service platform, they may merge different SDG resources together. Like for our local practices, one of our actions is to have a platform of the supported by the Case Earth SDG platform. And based on that platform, we have the SDG 13, SDG 11, and a few others, like 6 of them merged together with kind of interconnections with different kind of indicators to address the whole story. And from the collaborative part, I think they may include different levels besides the user part. From the development part, we may have the basic infrastructure layer constructions collaborated together, like the computing resources and facilities connect together between different sites to support the research of the same objective. And from the research resources level, I think the collaboration may depend on your research goal, like a certain research topic that you need data both within SD13 and maybe in others. Then we can just try to see if there is any models we can use. So I think in brief, the SD13 showcases already provide the kind of ideas or preliminary showcases. We are trying to get different research resources together, but that is a very early beginning. We will try to seek any potential kind of collaboration to make it more useful to the end users, either for research, for citizen science, and for something like this. So it depends on the service deliverable, the users of the services. Thank you.
Oh, great. Thank you very much, Lily. That is quite informative. I was wondering if I might follow up a little bit on that. And I'm, thinking about the theme of this session, sharing knowledge. I'm wondering about how your group might be sharing knowledge with other repositories. I know you're here today sharing knowledge with us, and we certainly appreciate that, but are you working collaboratively or coordinating with other repositories that are perhaps working on some of the other SDGs where some of the approaches that you're taking might be applicable to other data repositories that might take up on such approaches?
Sorry, Bob, the question is for me, right?
Yes.
Oh,
yeah.
Okay. Yeah, I think both. It depends on different projects. Like in the Case Earth, we collaborate with researchers and scientists from different SDG goals. And so under this umbrella, we will have the different data resources merged together to deliver a single sign-on platform to support the different SDG goals for research. And for the GEOSC initiative, the SDG showcases just focus on the climate change and the disaster mitigation goal. But on the other hand, we will have intersect study and internet connection with like the fundamental facility supports from the GEOS test bed, and we will have intersect connection with the policy group and things like that. So it's a kind of two different models for collaboration. One is among different indicators, different goals, and another is just focusing on the same goal, but we have different levels of research resources and services merged together. Thank you.
Oh, thank you very much for that, Lily. So are there others who have questions or if alternatively, if they would like to share a comment, we're certainly welcome to hear that. I don't want to be monopolizing the whole discussion, so I would like to give others an opportunity. And I see Devin has provided a great explanation to Ragil as well in the chat. Devin, did you want to elaborate a bit on that?
Yeah, Regil, I just was copying and pasting from my article. The topic you asked, and what and how is the role of the librarian to support? And so what I'm sharing with you is from the perspective of the participants in the focus groups, what role they thought librarians could play in data management. And so some of them didn't know or it didn't occur to them to discuss management of their data in the short term or long term with librarians. And I think those are the ones that were used to kind of doing their own data management and putting their data on their servers, and then that's it. And then we're probably not sharing it, and then, from that extreme to people that had used data repositories before. Most of them, if they had, it was because the journal that they were publishing in wanted them to do so, and they wanted to comply with that because they wanted to get the article published. But this just gives you a sense of the perspectives and the reasons why they thought someone should help and why they thought, what their ideas were about what role a librarian could play and why they should play a role or why they shouldn't. And it's their perspectives. I mean, I've already seen on Twitter, like some librarians are kind of fired up about what I found but these are actual scientists, scientists that are pretty prominent in their field. I mean, or they are publishing and presenting at major conferences in their field. And some of them don't have any idea what librarians do with regard to data management. I mean, it is what it is, but we can do more to explain what it is that we do to the different disciplines represented. And, that'll be a good thing because hopefully we can continue to raise awareness rather than like, oh, they don't know we've been doing all this for years. And yeah, well, they don't. Some of them don't. I hope that this rubric could be helpful if a scientist is engaged with a librarian and would like to know more about, or would like some guidance about repository selection, or scientists maybe themselves could use it, and it could have some of the considerations that people care about represented in it. Okay.
So is that the pushback that you're getting? Is it that the scientists should know?
I think some librarians are surprised that scientists don't know the work that librarians have done on these issues. I don't know if that's necessarily pushback, but it's a reaction. But it's the truth, because some of these scientists said, it never occurred to me to talk to a librarian about data management.
It's very interesting.
Mhm.
Yeah, well, it's the traditions of a lot of disciplines are changing, and as a result, I think we all have to kind of keep an eye on how things are changing so that we can take advantage of them. I'm seeing a message here from Paula Lackey. Paula, did you want to elaborate a little verbally?
I totally agree. I think that people, that there's a great deal of isolation within disciplines. And I just become aware of a project in Sweden where there's a librarian who's working to come up with vocabularies that match across, or no, that don't match, but that match with the disciplines in which she's trying to communicate data management. And I'm doing some work in Malaysia where we're trying to figure out what is the language of each of these disciplines, what is it that they see as data management, and this is outside of, this is well before you get to the point where I'm ready to deposit my stuff. This is trying to get to the point where open science is actually open science and people actually know what we're talking about. I think that the jargon in the field of data is such that you can be saying things about your data using data specific terms that are relevant in your discipline that mean something different in another discipline. And when you're communicating, you think you're saying one thing and they're hearing something completely different. So like in a case in point that's really kind of simple is I'm in IT and I do academic support, but I work with my librarians to teach data, different things about data management to students. And I'm talking about databases and I'm talking about sets of research data files. And a librarian steps in and she's talking about databases and she's talking about collections of journals, right? And between the two of us, we do the translation. But to the poor student who's never heard of a database, what is going on, right?
Yeah.
And we make sense, the statements make sense, and yet we're not actually communicating with the students. And, we stopped doing that, but that's something that I think people can relate to in terms of terminology. And this is not rocket science here. This is worse. Actually, you know what? It is kind of like rocket science because they used the wrong, what was it in the Hubble? Well, one guy used metric and the others used English measurements and they screwed up the Hubble for a while. That's kind of what we're doing. Anyway, that was my point.
That was one of the Mars.
Go ahead.
I was just going to say that was a Mars lander that crashed because they mixed up metric and English.
I mean, I realized when I had to do the rubric that I had to create a glossary that even defines what a repository is, because some scientists were like, well, what is it? So like there is a need, they don't talk about it the way that we do. So, yeah.
Yeah, and that reminds me for our study, one of the issues that we're finding is the way that different people are using the same terminology, but they mean completely different things. And so, you kind of have to explain exactly how you're using a particular word so that people will be able to talk about the same issues. Anyway, I believe that our session is over at it's 9 my time anyway, and it's been 90 minutes, over 90 minutes. So I don't want to keep people, but I certainly want to thank everybody for joining us today, and especially Lily and Devin and Kirsten for their great presentations. And so with that, I would like to wish you all well. And there's a final note here from Ragul saying he's agreeing with what Paula said. This phenomena is also the same as what happened in Indonesia. And Bob Chen has shared with us an article about the Mars Climate Observer Report. So with that, I wish you all good reading, and we hope to be seeing you soon. And thank you all.
Bye.
Again.
Thank you.
Bye-bye.
Hi, thank you.